All right, let's dive in. Today, we're talking about something absolutely fundamental in Python, loops. Seriously, this is one of those tools that lets you hand off all the boring, repetitive work to your computer. That way, you get to focus on the fun stuff, the actual problem solving. So let's get right to it. So let's start with the why. I mean, why do we even need loops in the first place? Well, it turns out they solve a super common problem, something that I guarantee you've run into before, probably outside of coding too. Just think about it for a second. Any task, any project, what's the most mind-numbing, soul-crushing part of it? The part that makes you just want to stop? Yep, it's having to do the same thing over and over again. It doesn't matter if you're working with one piece of data or 10,000. The steps are usually identical. And doing that by hand, it's slow, it's boring, and you're just asking to make a mistake. And that is where loops swoop in to save the day. The whole idea is simple. You write the instructions just once, and the loop takes care of repeating them as many times as you need. This is a total game changer. It saves you a ton of time, and way more importantly, it cuts down on those little mistakes. This really is the heart of writing smart, efficient code. Okay, so let's get our hands dirty with the first and probably most common type of loop you'll ever use in Python. It's the for loop. Think of this as your workhorse, the tool you'll reach for whenever you need to go through a bunch of items one by one. So what is it exactly? Well, a for loop basically looks at a sequence, like a list of names or a bunch of numbers, and it runs a chunk of your code for every single item in that list. It works on anything that's iterable, which sounds technical, but it just means anything you can go through one item at a time. Simple as that. Check out this example. It's super clear. We've got a list called names. The for loop is basically saying, in plain English, for every name, which we'll call N for short, that you find in the names list, print hello and that name. And that's it. Python does all the heavy lifting, going through each name until it hits the end. So clean, right? Really easy to read. Okay, that's great for lists, but what if you don't have a list? What if you just want to do something, say, 5 times? Well, that's where a super handy function called range comes into play. It's the perfect partner for a for loop because it creates a sequence of numbers for you, right on the spot. And the cool thing about ranges is how flexible it is. You can use it in a few different ways. The simplest is just giving it one number, like range of 5, and it'll count from 0 up to, but not including 5. Or you can get more specific and give it a starting and an ending number. And for even more control, you can tell it how big of a step to take each time. So you can count by 2s or by 10s or whatever you need. For loops are awesome when you know exactly how many times you need to repeat something, like for every item in a list. But what if you don't? What if you need to keep doing something until a certain thing happens? For that scenario, we have a different kind of loop, the while loop. And the key, as you might guess, is right in the name. A while loop will just keep on running over and over for as long as, or while, a specific condition is true. The very moment that condition flips to false, boom, the loop is done. Let's look at a classic example. We set up a variable called count and start it at 1. Then we tell the loop, hey, keep running as long as count is less than or equal to 5. Inside, we do 2 things. We print the number, and then, and this part is absolutely critical, we add 1 to count. That little count plus equals 1 is what guarantees that eventually count will get bigger than 5, the condition will become false, and our loop will stop. And this brings me to a super important warning about while loops. If you forget that step, if you forget to change the variable inside the loop, your condition might never become false. And when that happens, you get what's called an infinite loop. Your program will just be stuck running forever. So you always need to make sure your while loop has a way to end. Okay, so we've got our 2 main types of loops, for and while. Now let's level up a bit. Let's talk about how you can get even finer control inside a loop. We can do this with 2 powerful keywords, break and continue. Think of it like this. Break is your emergency eject button. The moment your code hits break, it completely bails out of the loop, no questions asked. Continue, on the other hand, is more like hitting the skip button on a song. It doesn't stop the whole playlist. It just skips the rest of the current song and jumps straight to the next one. All right, let's see how this works in practice. We've got a while loop here that's counting down from 5. But notice that little if statement inside? It's watching for the moment n becomes equal to 2. When it does, we're telling it to break. So what happens? Take a look at the output. It prints 4, then it prints 3. But the next time through, n is 2. Our if condition is met, the break command runs, and the loop just stops, dead in its tracks. It never gets a chance to print 2, and it just jumps right out to the loop is finished line. Okay, now for the fun part. What if we take that exact same code and just swap out the word break for continue? Take a second and think, what do you expect to see happen this time? And the results is totally different. It still prints 4 and it still prints 3, but when n hits 2, the continue statement kicks in. It tells the loop, hey, you're done with this round, skip everything else and go straight to the next iteration. So it skips the print command for the number 2, but then it happily keeps going, printing 1 and 0 until the loop finishes naturally. All right, enough with the theory. It's cool to see these little examples, but let's put it all together. How would you actually use this stuff in a real-world situation? Something you might actually code up. Okay, here's a super common job. You have a list of numbers, and you need to find the first one that's divisible by 7. So, what do? We set up a for loop to check each number. Inside, an if statement checks if the number divided by 7 has a remainder of 0. As soon as it finds one, boom, there's 21, it prints out that it found it, and then it hits that break statement. Job done. No reason to check the rest of the list. And this is why this is so important. I mean, with a tiny list like this, who cares, right? But what if that list had a million numbers in it? Or a billion? Using break means your program stops the instant it finds what it's looking for. You don't waste time and computer power checking thousands or millions of extra items you don't need to. That's the difference between clunky code and really efficient code. So there you have it. You've now got the core tools to take on pretty much any repetitive task. You know how to go through lists with for loops, how to repeat things with while loops, and how to control them both with break and continue. You can make the computer do the grunt work. So the only question now is, what's the first thing you're going to build?